Hello students, welcome back. This is module 5.2.1, Taxonomy. And taxonomy is, of course, a necessary endeavor. After we have the evolution of millions of species on the planet, we need to, one of the tasks that falls to biological scientists is to figure out what the relationship of these many species are to one another. And that's one of the things that taxonomy does. Taxonomy may be defined as a science of identifying and naming species. Closely related to taxonomy is the endeavor known as phylogeny. Phylogeny is a systematic study of evolutionary relationships among species. Now, what a taxonomist most wants to do is they want to create a phylogenetic taxonomy. So they want to kind of combine the two. And in this phylogenetic taxonomy, they hope to trace the path of evolution so that their system that they come up with will mirror the path of evolution and show genuine evolutionary relationships. Now, we have all sorts of classification systems, and what they do is they organize and simplify information about systems. Perhaps a good way to understand this is to consider the chaotic grocery store. This grocery store isn't chaotic, it's organized. But I want you to consider an imaginary grocery store, one in which there really is no organizational principle. So in one aisle, there's not a bread aisle or a cereal aisle. So if you're looking for Captain Crunch with Crunch Berries, as you see on your screen there, you might find one box of Captain Crunch with Crunch Berries on one aisle and another one on a different aisle. And the other Crunch Berries, Captain Crunch cereals, regular Captain Crunch and peanut butter Captain Crunch, will be found scattered all over the store as well. And so it would be with everything. And that's very similar to the way that species are distributed in the natural world. They're not in nice, neat aisles and organized in a system. That is, in fact, what classification tries to do. Using a phylogenetic taxonomy, biologists will try to organize the information so that it makes sense, all the species in the natural world. And this photograph here on the right is just meant to show a forest and the great crush of species, even though it's only showing plants. Think of all the animals and the microbes and the fungi that aren't visible there. So classification has been something that biologists have been trying to do for a very long time. This gentleman whose picture we see in the upper left is Carl von Linné. He is known as Linnaeus. That is actually the Latinized form of his name. He was from Sweden, and he was considered the father of taxonomy. He was one of those guys who had a place for everything and everything in its place, really organized things. And so in the 1700s, he was working on this hierarchical system of taxonomy, and organisms were placed into ascending groups of increasing inclusiveness, starting from the species. And I know that doesn't make much sense when I just say it like that, but we'll show you in a minute what that means. Okay. For now, we want to tell you about one of the latest categories of taxonomy, and this is the domain. It used to be the kingdom was the highest grouping, the broadest grouping, and now it's domain. And so domain is a grouping of kingdoms. And so a domain is a classification grouping or a taxon that's broader than kingdom. There are 3 domains, and all living things fit into this. There's about 1.8 million described species, species that have a scientific name, species that have a written description, and species for which we have a specimen, what is called a voucher specimen, in a museum somewhere. And so that's what it means when a species has a scientific name. In any case, the first 2 domains are all bacteria. They're only one-celled prokaryotic organisms. The third domain includes some one-celled forms, but it also includes all the multicellular organisms. And so all the animals and plants and fungi that you probably are familiar with fall in domain eukarya. But there's more genetic distance between domain archaea and domain bacteria than there is amongst all of the organisms that are found in domain eukarya. So that's quite a Quite an interesting thing. So now let's look at the taxonomic hierarchy. The basic hierarchy is like this. Domain is the broadest, and then we go kingdom, phylum, class, order, family, genus, species. So if you look at this, again, as you go up toward the top, toward domain, this is the broadest. So only three groupings include 1.8 million species. So as we get to the very bottom, species only includes one species. And we can see that there are intermediate categories. And as we go up, for example, one class contains many orders. One order contains many families. One family contains many genera, which is the plural of genus. And one genus can either have one species or it may have many, depending. It just can vary. You definitely do need to know these categories. You need to know domain, kingdom, phylum, class, order, family, genus, species. So you have to come up with some way to remember that. One thing that will help you to understand kind of how the system works is a geographic analogy. So the domain can be like the star system, in this case the solar system. It was called the solar system because our star is Sol, or the sun. Kingdom is kind of like Earth. There are many planets in the solar system. Well, there's 8 planets. We demoted Pluto. And there are phylum is like the country, and so there are, I don't know, somewhere around 200 countries in the world, and the United States is one of them. Class would be like state. There are 50 states, and so order would be like a county, and family would be like Sierra Vista. Genus would be like the street. For example, consider Colombo Avenue, and species would be the street number. 901 Colombo is the address of the Sierra Vista campus of Cochise College. So I hope this helps you get a feel for the way this system works, that we get down. People do talk about Colombo Avenue, but they don't talk about 901, and that's the way it is with genus and species, as you'll see a little bit later. But here's some ways that some mnemonic memory devices that can help you to remember domain, kingdom, phylum, class, order, family, genus, species. I don't know. None of these are that great. Here's one. I don't know that this is that great either, but it's memorable. Do keep privates clean or forget getting sex. Ho, ho, ho. Very funny. But the point is, it doesn't do you any good to remember the mnemonic. You need to remember what it stands for. So domain, kingdom, phylum, class, order, family, genus, species. And this actually, I like this diagram quite a bit here because it kind of turns it upside down. Before we had domain on top, but it puts domain on the bottom. And if you can make that little mental adjustment, there are 3 domains, and this is showing domain eukaryote, so one of the 3, and there's only a handful of kingdoms in there. And so this is one of the kingdoms, Kingdom Animalia, and the Kingdom Animalia contains many phyla, and so this shows one of the phyla, and then many classes, and then many orders. And until we get down to genus, and there's only one species, Panthera pardus, which is the leopard. And so this actually explains it well. So if you didn't understand the solar system in the geographical analogy, maybe this portrayal here will help you to understand it. Now, a real important idea to remember in the context of taxonomy is binomial nomenclature. And that literally means two-name naming is what binomial nomenclature means. It was developed by Linnaeus, and it's used to name species. Now, every species is given a 2-part Latinized name consisting of a genus and a species. And the genus is the first part of the scientific name. It is capitalized and it is italicized or underlined. Species is the second part of the scientific name, and the first letter is lowercase, and it also is italicized or underlined. Italicizing is how you do it in print, but since we can't really write italics, at least I can't, we typically underline. And so here is an example that I think not only should you remember the form of how scientific names are written, but in this case you need to remember this particular scientific name because this is a scientific name of your species. It's Homo sapiens. Homo means man or human, and sapiens means wise. So we have modestly named ourselves wise man, as you will. And so you would write it underlined, and as it would appear in print, it's here. It's italicized. And so you need to know that this is what a scientific name is, a genus and species, and appearing that way. Now, all of the other ranks or categories of taxonomy, they're also called taxa, singular is taxon. All the other categories, all the other taxa above genus are simply capitalized. And so think of a scientific name as like an address, and that the genus is like the street and species is a number. Genus, like a street name, can stand alone, while species, like a street number, is typically not used alone. Think of the genus Canis. Canis refers to a member of the dog genus. But if you hear the word latrans, that doesn't mean anything alone. But you put it together, Canis latrans, that means a coyote. And in fact, latrans in Latin means barking. So Canis latrans is the barking dog. And just to show you an example of another scientific name closely related to this one, Canis lupus is the wolf. And so that kind of gives you a feeling for how scientific names are used. So you should definitely remember your scientific name, Homo sapiens. There's no such thing as Homo sapien. The species name sapiens ends in an S, and it never appears without the S. So do remember that. And with that, we will conclude this module.